All right. Waiting for my buddy to join. We're on the thingy. Let's see how I get this thingy over here. Bring that thingy over here. Oh, that's too big of a thingy. Minimize that thingy. There we go. All right. Right. Share. All right. Save. There we go. And then, all right. We're gonna be doing AMC 8, numbers 16 through 25, I believe, for 2025. And again, waiting on my buddy. Sending them a message. Got my fancy pencil thing here. Oh man, this thing's so cool. Let's see. He usually does screenshots for the test, but I guess I can put question 1 up there. AMC problem 16. There we go. I guess I can just try to paste it in here. There we go. There we go. Add stage. You there? Can you hear me?
Mm-hmm. Yeah.
All right. Yes.
Can you hear me?
Got some. Have we? I don't think we've done this one before, have we?
We could have, and I wouldn't know.
We'd still struggle.
Yeah, we'd still struggle through it. You like my? I renamed the whiteboard room.
Yeah, number 1 ST to the left. What's ST?
Standard deviation.
One standard deviation.
Maybe two.
Yeah, I was gonna say 1's being quite generous.
Yeah, you're welcome. I was averaging you in to move us to the right a bit.
Yeah, that's the right. Yeah.
All right, so we're doing 5 distinct
integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? So first of all, that probably tells you it doesn't really matter which numbers are chosen.
As long as they don't differ by 10.
As long as they don't differ by 10.
Okay. No two numbers differ exactly by 10. Oh, okay, so like if you chose 2, you can't choose 12.
12, right.
So that means every number has to be, that kind of sets it all, doesn't it? Because as soon as you pick your first 5, you've picked your next 5, because there's only 10 in each chunk. So yeah, do one. Should we do one?
Yeah.
Just like pick some numbers, see what happens.
All right, there you go. Yeah, my thing wasn't right. What color do you want to be? Right now, mine's set to green. Do you want green or blue or black?
You got green. You got it. I will choose orange.
Orange. Aren't you glad I didn't say?
Wait, I can choose any color in the rainbow. Okay.
Yeah, any color. You are free. The world is your oyster.
Yes, this palette is my.
2.
I'll choose a darker shade of blue.
My handwriting's atrocious. Okay. Blue.
Okay, so if you did that, then we would have
16, 17, right? And so then.
Okay, what if we did every other while you're doing that?
6, 10, 15. Oh man, these are big numbers.
Yeah, so every pair, we could probably pair them up in a way that they're.
I don't think it matters, right? Isn't that the point?
That's what I was gonna try and figure out why. Like, to me, it looks like you can make 21s everywhere. Is it same for you? Can we make 21s in your group? Yeah, like if you do. See what I mean?
Yeah.
It looks like no matter what you do, you're gonna have 5 sets of 21. So I'd go with 105. Because if you look at mine, it's the same situation too. Over there.
23. That was a 19. That was bad.
You can always make 21s.
25. And, oh wait, no, that's not 25. It's 23. Oh, I got messed up somewhere. 23. This is 19. 3 plus 18 is 21. That's where I got messed up. 21. This is 23 and then 25. So yeah, you can do your 21s, or the sums are always going to increase by 2.
Mm-hmm.
Like, because this is going to be 13, then this is going to be, I guess that's going to be 17. So I guess it increases more. This is going to be 11.
Oh yeah, those increase by.
4.
Yeah, it depends where you pick.
Yeah.
I feel like there's no way to. So if you pick a
20, 25.
Because you have to pick a number, either 1 or 2. Like you have to, right? You have to pick from every pair.
Right.
Is that a correct conjecture?
So was it 100? Did you get 100?
I got 105.
My
How'd you get 100? Did you add
Yeah,
those up?
105. 105. Yeah.
Because I did 5 times 21.
Yeah. 7 plus 3 is 10. 9 plus 1 is 10, and then the 5. I forgot the 5. Yeah, 105. So it's definitely 105. I wonder why that is. Yeah, I guess that's what we were trying to figure out. Why is that?
I was gonna say with every, you have to take one of every pair, right? Between 1 and 2, you have to take one of them because otherwise you run out of numbers. If you take any consecutive numbers, you know what I mean? Like if, oh no, but you took one. No, you took consecutive. Never mind. I'm saying nonsense. But then that eliminates the first 5 of the next one. So for every number you choose, it eliminates the 10 more, but does it necessitate another number?
I think your idea of 21s was pretty good. That the average, no matter what you do with these ones, like your average is always going to be 21. The average of these 5 is always going to be 21.
Yeah. What's the sum of all 20?
What?
Like if we just added up all 20 numbers, we should be able to do that. I should be able to do that. 1 plus 2. If we just said we took all of them.
Oh, yeah. Oh.
Isn't
Well, you
there-
start with 20. You can start with 20, and then you're going to get another 20, right?
Oh.
And you're going to get another.
Yeah,
20.
wouldn't that be the Gaussian method, right? It'd be 20.
Yeah.
So you could pair up how many 20s? Or you could pair up a bunch of 21s. You could pair up 10 21s. Yeah.
Mhm.
You'd have 10 21s and you're going to take half of them. There we go.
Right.
That's probably the way they want you to think about it. Maybe. I don't know.
Well, they have a lot of solution sources.
Yeah.
You want me to check? I got the
wiki open.
No, I got the solution set on AOPS.
Yeah, that's what I meant. Their wiki. Yeah.
What is it? 16. So the first one they did is they just add them all. So they're just trying to get the correct answer. Another way to complete it is the 21. They did the 21 thing. One efficient method is to quickly add 1 through 10. And then because you took 50 in total away from 16 through 20, you add 50. I don't understand that one.
One efficient is quickly add 1 through 10 was 55. Then because you took 50 away in total from 16, 17, 18. I'd have to think about that one a bit more. I think they're saying because you didn't choose whatever you, oh, right, because the 10s, they're 10 away. Interesting. I'd have to say, I think I get where they're going, but I'm not there yet.
Yeah, I'm almost there, but I'm like, what? I feel like there's a logical leap they make that I'm not quite following.
They probably did, because they're probably one SD to the right.
So that makes us like 2.5 SD different.
At least. Okay, well, that's
yeah.
cool. Look at all the solutions. Oh, they have video.
Yeah.
People put up their video solutions. That's great. So you won't get copyrighted. Cool.
Well, at least not for AMC. We didn't think we would for AMC.
Yeah, we wouldn't, because this is all public. Yeah. Let's not put this YouTube link up there. Someone's gonna find it and put it on there. We better watch the wiki. All right, we got it though, right? The answer was
Yeah, we
C.
got it. We got it right. Answer C.
That's cool. That's the point.
Talk one,
And have fun.
talk one down.
Right or not, I don't even care if we miss one. Learn something new.
Yep. Hey, are you copy and pasting in there? You did it better than I.
Oh, I would have to join the board again as a second person. Let me do that.
Oh, okay. Well, you don't have to.
No, it's not hard. I just I'm on my Surface, so I can write instead of use my mouse.
Right. Yeah.
But I'm talking to you on the laptop. But I can join twice. I was there double earlier. I just got to open up the test. Let's see, where is the test? Are these the answers or the questions? Okay. Yeah, that gives me both. Is there a way to open it with that? Oh, there.
Mm-hmm.
I don't want to see the answers.
Yeah, go to the
there we go. I found
problems and then
Got it.
scroll on down.
Ooh, this looks like a graph theory or something.
Did you ever get this shirt? Did you get one of these jackets?
Hold on, I can't see. I'm taking a screenshot and it froze you.
Oh.
Okay, now I can. Did I get one of what?
One of these ones?
I think, was that Terry? Terry's year?
Is that Terry's here? Maybe. They were nice jackets. Mine just has shrunk over the years.
Washing it. Yeah, it's yes.
Yeah, I believe it. Yeah, it's the dryer's fault.
It's a dryer.
Oh man, this looks complicated.
Okay, I'm getting it, trying to get it on your screen.
In the land of Markovia. Good old Markovia. Yes.
Here, been there.
I get expand. You've been there?
No.
Oh, that did not work. I thought it was.
That's like, I can make it smaller too after we read it. So the land of 3 cities. Okay.
There are 100 people who live in A, 120 who live in B, 160 who live in C. Everyone works in one of the 3 cities, and the person may work in the same city where they live. In the figure below, an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second city. For example, 1/4 of people who live in A work in B. How many people work in A? Whoa, okay. I got to go back and read that again.
Yeah, I think I got it. Not the answer, but the question.
There are 100. Okay, so I got that. Everyone works in one of 3 cities. A person may work in the same city where they live. And figure below. Okay. So this is telling me, so of the 100 people in A, 1/4 work in B. Of the 100 people who work in A, a fifth work in C, and then that leaves the rest working in A, correct?
Mm-hmm. Right, so that, I think you're onto it. We just got to do those 2 things, and then I think it's just a bunch of fraction problems.
Fraction problems. So that's 5. Oops, I did not mean to do that. Sorry.
I'm working off to the side. So.
Yeah.
I've got an answer.
What? Why are you always so quick at this?
Well, it might be wrong.
So yeah, 5/20ths work. And then
Wait, what are you doing?
I'm
You
trying to
taking
figure out a
1/4?
fourth. Yeah, 1/4. And then 1/5 is 4/20ths, right?
Why are you converting it to 20ths? It is, yeah.
I don't know. Is there a least common denominator before then?
No, it's not.
Between
I'm just
4 and
curious how the inner workings of your brain. So you're
That's a
finding 1/4 of 100 and
yeah, 1/5. I guess I don't need to know that, huh? Because I could just figure out it's like 25 and 20, and then
yeah.
that's 45. Oops, I didn't mean to write on that one.
But we want and we want the people that are in A, so that's
So
55. Yeah.
that's 55. But then we have
Yeah.
1/8 of that.
That's 60. Yeah.
So 160 divided by 8 is 220. All right, so let's add 20 to this. And then B, we have 1/3 of B. So that's 40, right?
Mm-hmm. That's what I got.
40. So
We're in
5,
agreement.
5, 9. Well, don't say that yet. I haven't finished my math. I could get it wrong. 115. Oh,
Yeah, I agree. So that's probably a bad sign.
here comes the dog. Hi, puppy. Oh, there you go. I guess he was fussing. Had to be let out. He probably heard me. Like, oh, I hear him. So, yeah. All right. Are we checking that? You want me to check that?
I checked it. It's right. And as
It is right.
as anticipated, there aren't nearly as many solutions because I don't think there's really too many creative ways to do that one.
There are just not time efficient ways.
This model is known as a Markov chain.
Oh.
A stochastic process? What?
Stochastic. I've heard of stochastic processes.
What is that?
I don't know. I just said I've
They
heard of
might
it.
say, so they say a type of stochastic process that models systems where the next state depends only on the current state, not on the sequence of events that preceded it.
Yeah, it's a static. So you just look at it as it is. That's the static is the key to stochastic.
This is known as a Markov property, memoryless. That's hard to say today. Memoryless.
Memory
Less property. Memoryless property.
There you go.
That model where the next state depends only on the current state, not on the sequence of events.
Yeah, so it doesn't matter what happened before here or what happens after this. You know, if city D joins their little tricipality to make it a quadcipality, it doesn't matter because right now this is what's going on at this exact moment in time. Okay.
All right. I don't know why that matters, but I believe it matters. But I don't know why. You want me? I'm gonna clear it.
Yeah, we're clearing it. Yeah. Oh wow, how'd you clear it so quick?
There's a button called clear.
What?
Yeah.
Goodness.
Skills I picked up over
the eons.
Years of tutoring. Not any math skills, as you see, but I can handle this whiteboard a pro.
Quite well. Hey, that's something.
Oh, this looks fun.
All the circles, always circles.
Okay.
Oh,
What do we have?
It's not quite on there all the way.
Oh. I'll shrink it a bit. I have a song in my head. To the left, to the left. Everything I own in a box to the left. Everything you own in a box left.
The circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. And the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the two circles have the same area. What is the radius r in units of the circle on the right?
Oh.
Oh no, don't start pressing.
Okay.
Okay, but what? They're different units?
The first 4 sentences could be just look at the picture.
Right.
The shaded regions have the same area. Okay.
Same area.
So we need to figure out what that is, I'm thinking first. Then once we know that, we can probably figure out something about the bigger circle. Yeah.
Why is the dog fussing?
So anyway, before I would think too hard on it, I would just try to find the area of the shaded region, which we should be able to do.
On the little circle, right?
Yeah.
Because you got a box in the circle, so you have the area of pi r squared.
Right. So the whole circle is pi.
Pi.
So we got to subtract the box.
And the box is 4 units. That doesn't make sense because pi is what's the.
No, that's not.
Oh, that's not because I always do. That's yeah. It's
we have to find
yeah, I was doing the hypotenuse, not the leg. Yeah,
we have to find that.
So it's x. So it's a square root of 2, right? Or not. It's goodness. I can't speak today.
It's
square plus b squared.
Yeah, square root of 2. Yeah. No, wait. So it's a 45. It's a 45, 90. X root 2.
Oh, I want something different. Get out of there. That was weird. Yeah. Plus 2x2, and then do the square root of 2x2 is what that length is. Although you used x there, so we'll say this is y.
Isn't it root 2 over 2? Would that be the length
of the whole thing? Could be.
No, not the whole thing of the trig. You have to double that. So root 2. I think each side of the square is root 2.
I'm going to trust you on that.
So the area of the square would be 2. Well, because it's a 40, right? That's a 45, 45, 90 triangle, right? If I draw the one I drew in there. If you draw the, what's it called? Is it the apothem or is that just for like other stuff? But basically straight down from the center to the side.
Right. Yeah. Yeah.
That's an isosceles triangle.
Right.
Which I don't want to prove because I don't remember how, but so it's 45, 45, 90.
Yeah.
And that we know
yeah.
The hypotenuse is root 2 times the leg. So therefore we have to do the leg divided by root 2. Or the hypotenuse divided by root 2, sorry, to find the leg. Does that sound right?
Wait, why did you root 2 the leg? So are you this is good. I understand.
Yeah, so we're given this.
Right.
And we're trying to find that.
Right.
So to find that you have to divide by root 2. The hypotenuse, because right, if you take x over root 2 and divide by root 2, you would get x. And that's what we're trying to find. So the hypotenuse divided by root 2 gives you the leg.
Yeah.
Because if you knew the leg, you would multiply by root 2 to get the hypotenuse. So we're going backwards. We know the hypotenuse and we're finding the leg, so we divide by root 2.
So my simple brain goes back to this: x squared plus x squared equals 1. right? Is that what you were doing? And so you had 2x squared
Nice. That will
equals
get you
1.
there. You're
Is
proving it.
that where you're getting it from?
That's going to get you the same thing. So the triangle I drew is the shortcut to that. You're proving that it's the same. Yeah. Yep.
X squared equals 1 over 2. And square root.
Should be 1 over root 2. Yeah.
X equals, because square root of 1 is 1. And then
square root of 2 is square root of 2. And then
so 1 over root 2. All right.
And then you remember rationalizing. So you multiply by root 2 over root 2 to get rid of that root 2.
Oh, okay.
Do you remember that trick?
Yeah. Well, I mean, that's just multiplying by 1, right?
Right. Just to get rid of the radical.
You can't
in
have the
denominator.
root down there.
I mean, you can, but it just makes it worse.
So then root 2. That's
Over
it.
2.
Right?
Root 2 over 2.
Root 2. Right.
And then that's half the side, so we double it to get the side, because that's just half of the side.
I don't know why. He hates when I'm on the computer.
The sound was quite loud.
Yeah, so then the 2's cancel. Hey, I'm right here. So
He's
then
your
the 2's cancel out square root.
He's your technology accountability partner. He's like, you've been on a screen too long. 5 minutes.
5 minutes. You have not played with me. You need to go out and take me for a walk.
So we're in agreement that the square is of root 2 length, so that then the area would be 2.
Right, yeah. 2 times, yeah. Square root 2. Hey, we hear you.
So can we get rid of him?
So the only way I got rid of it, I got him to stop doing this last time, is I brought up that chair. Remember, I brought up like a whole big chair and put it next to him so he could sit right next to me.
That's so funny.
He's mad because he's not sitting next to me.
Yeah. The dog's awesome.
Oh. All right, just a sec. I'm gonna go see who needs to go out.
That's fine. I'm gonna think, I guess.
Oh. Come on. Do you need to go outside?
I feel like we're doing more work than we need to.
Yeah, well,
that's okay. It's fun. I feel like there's something we could do with ratios, like if that area is 4 times bigger, then wouldn't the radius be twice as big? So if I was gonna do an initial guess, I would go with 2. We'll see what the host thinks. Did you hear anything? You probably didn't hear what I said, or you did?
Yeah, I heard you.
You know what I mean? Like, so going, like, we started from a different angle, right? If we're going to assume the triangles grow in purport, which they would, if that shaded area is 4 times bigger than the other one, right? So this one is 4 times bigger than the other one. Does that mean the circle is 4 times bigger in area? Is that a reasonable assumption? And if it is, the radius would be twice as big because it's radius squared.
So you had a 4-to-1 ratio, and then you have a 1-to-r ratio, right?
Right.
And so you'd say 4
you got
over
those backwards,
1
though, I think.
Equals 1 over r. I don't think so.
Well, whichever. The 4 would go with the big R, right?
No.
I'm not sure. No.
4,
okay. Keep going. Keep going.
Because you have 4 of these. That's where the 4 comes from. These 4 guys. 4
I thought it was
guys
area. Okay.
Equals
1 of those.
1 of these guys. So then 1 of these guys is relationally equivalent to that. That's where I got that.
Okay.
So I mean, oh, so then when on the setup, right, it should be 1 over, I guess you do 1 over 4, and then R over 1, if I'm trying to use the same. Did I mix up my fraction down here?
You're saying 4, that would be 4R equals 1. So R would be 1/4. I think you got it reversed. That would
I
mean
got it.
R,
So my first one was more better.
probably. But still, I don't, but you got to take in the fact that area is R squared. So if the area is 4 times bigger, the radius is only twice as big.
Oh,
Because you're going to square the radius.
right.
So I
So
think
you're saying these, to make these ratios,
I'm saying if
the equivalency is, radius to shaded area is not a direct equivalence. It's
it's a square area.
2R,
No,
or
R squared.
R squared.
Yeah. Like if you triple the radius, you will increase the area by a factor of 9. Yeah.
Right. Oh, okay. So yeah, so then you could use that.
Right. So if the intuition is right that circle's 4 times bigger, it's
So
really
it would be
easy.
R squared, like that. There you go. So then you have,
You still have it reversed, but yes. You'd want 1 over 4 because that would say 4R squared is 1, so R would be a half. And that's backwards. We want R to
okay.
be
So
2.
so the second one was correct. I just didn't have the R squared.
I don't know.
Yeah, my second one was correct. I just didn't have the R squared. So I had 1 over 4 equals 1 over R squared.
Yeah, that's the way I was thinking originally, because the 4 goes with the bigger circle, because we're talking size, not number of regions. Yeah.
R squared square root 2 equals R. All right. That's what you said like 10 minutes ago.
Well, yeah, but we could keep going with the path we're on. That's the fun of it. Like what? So we had found the area of the shaded region is pi minus 2.
Yeah, I don't know how to do. I'm not good with these arc regions. Like that's.
Well, you just find the area of the circle and subtract the square. So then we would have to do the same thing in terms of R, like generically, I'm guessing, and then I don't know, it might be fun to try. So in other words, if we did the same thing, the length of this side, can I clear up a little bit of stuff? Yeah. So if we drew the same triangle, and we're finding the length of this side, that would be R over root 2, which is R root 2 over 2. So then the length of this each side would be R root 2. Is that right? I don't know if this is going to go anywhere, but
Sure.
So then the area of the,
following.
I just found this, the length of the square the same way we did with the 1, but I just used R.
Yeah. Okay.
So then the circle, the area would be pi big R squared minus, and then it would be 2R squared. R root 2 times R root 2 would be 2R squared. So that would be R squared times pi minus 2. That's the area, and then if we subtract pi minus 2.
You're off screen.
I'm off the screen. Wait, have I lost my way? Are you in all where I am?
No.
Good, because I don't know where I am either. Let's see if I'm right. Okay, so we got the area of the shaded, all the shaded region over there is pi minus 2. That we're in agreement, right? That's all these. Okay.
Yeah.
The area of the big circle is pi big R squared. Right? The area of the circle to the right. Okay. We found the square side length is R times root 2.
So it would be pi minus 2 equals pi r2 minus pi 2r squared.
It'd be pi r squared
Like
minus.
these two are going to equal each other.
Well, that's what I was factoring out the r squared. We have to also divide this by 4 because, or we have to, oh no, wait, it's going to be equal to it. No, we don't.
Oh,
So,
you
yeah.
factored out. Okay, you took out the r squared. That's what you were doing.
So we have r squared pi minus 2 minus pi minus 2. So now we could factor out the pi minus 2. And that's r squared minus 1. Does this tell us anything?
I don't think it tells us anything.
Yeah, we need this to be equal to something. Why? I didn't want to subtract. No, it's equal to pi minus 2, not minus it. Wait. So hold on. Let me change color. This is the area of the big circle minus the square.
Oh, but that's getting all these.
So we got to divide by 4. And then we got to set that equal to pi minus 2, not minus it. Yeah. Okay.
Oh, yeah, that's what I said. Yeah, these are equal, but I was forgetting the divide by 4 part. That's what I was forgetting.
Okay, so let's get that whole thing. So we got to divide that by 4. So that's going to be pi r squared over 4 minus r squared over 2. And that's going to be equal to pi minus 2. It's probably easier just to leave it all over 4. Whoops.
Yeah.
Because we can just multiply both sides by 4. So let's just do that now. So we're going to multiply this by 4. And then it's going to be pi r squared minus 2r squared. Okay.
My buddy Ron's watching. Hey Ron, you can come on, join. You can give your commentary.
Or help us. We're struggling so bad. I shouldn't have put that in there.
I like Ron.
Okay, there it is. We did it. Look.
Wait. Oh yeah, you cancel those out. There you go. And then square root.
And we only want the positive root. It did work that long way.
Yeah. Huh.
Cool.
I mean, Ron, it could be like watching the video games, He likes watching video game streams with some of the guys and talking. And he's yeah. So yeah, you come on, Ron. You do it. Kevin is he's the factory of sadness, and he's a math teacher, so he knows these things.
Don't say that on this. Now you got to delete this video.
Oh, now I got to delete. He's not a math. He's a factory of sadness.
I'm a middle school math teacher. Okay, let's lower the expectations.
So Ron, he was over by your neck of the old Stompin' Woods. He was in Northern Ohio the other day, and he went by the duct tape factory. Did you ever go by the duct tape factory?
Where in Ohio?
Like northern Ohio? I don't know. Ron, where?
Ohio's a pretty big state.
I don't think he's on anymore.
We can look.
Yeah, we could look. I could look it up. I got this thing called the internet.
I'm looking up our answer.
Tape.
The answer was 2.
Factory.
Solution 1 was our solution 2. Solution 2 was using trig, which we basically did. We just cheated.
I think that's.
Oh, there's shirt tape down here too.
Oh, okay.
There's a big shirt tape factory in Hickory, I think.
Yeah.
Maybe I'm wrong.
But yeah, that looks. Yeah, just on the other side of Cleveland. Looks like it.
Yeah, I never get over there. Avon Lake. I've been to Avon Lake.
Oh, Avon. Yeah, Avon, Ohio. There you go.
Brea is where the Browns are.
Mm-hmm.
Yeah. That's why I don't go over there. It's just too much sadness. There's a factory and then the sadness. Right next to each other. You can just call me Sure Taperia, Factory of Sadness.
Yeah, that's so ironic. That's so weird that they're both in those locations. Yeah, it's very sad. So
I love Solution 9. Do not ever use this, but yet they put it on the wiki. I don't understand what it said. And then they wrote it like 3 times. Please don't use this. I love the AOPS kids. They're so great. Okay.
So what was that? What was Solution 9?
I didn't even read it. I was skimming. I'm ready for another one here. Let's go. We're crushing this.
We're
6th grade style.
It's like the boys talk.
Number 19.
He had a bad dream. Some bad guys were after him.
Yep. Go and beat him up.
2 towns, A and B, are connected by a straight road 15 miles long. Traveling from town A to B, the speed limit changes every 5 miles, from 25 to 40 to 20 miles per hour. 2 cars, one at town A and one at town B, start moving.
Oh my goodness. 2 trains, one going east, one going west. But these trains change speed every 5 miles.
At the same time, they drive exactly the speed limit in each portion. How far from town A in miles will the 2 cars meet? So how far from here? Okay. So.
Well, there's probably the brute force way we could do it. There's probably a more creative way.
Mm-hmm. There always is.
Can we average the speeds? Because no, let's see. But you're not going to get there the same. Would that work? So my first, since the distances are the same, could we just average them?
Yes.
But the average is terrible. Nobody wants to average that.
Why not?
Because it's not divisible by 3.
It's 80, 85. 85 is not divisible by 3.
Not in base 10.
Well, that's
maybe in your number system.
Base. Yeah, that's what I'm saying. See, my number system, all this will work out nicely. It'd be beautiful.
Do you remember the shortcut to test if something's divisible by 3?
No.
You add the digits, and if the sum is divisible by 3, it is also. I actually learned why that's true. I never was told why, and I never cared. I thought it was complicated. It's totally not complicated at all. It's like something a child can understand, which is why I understood it.
Yeah. All right. So that's like 8. Right. Yeah. 20.
Yeah. Okay. Well, that's true. So 28. Is that right? In a third.
1/3.
If that was helpful in any way, we would have. That's per hour, and they want to go a quarter of that, so they're going 7. Well, that doesn't work because one's going 20.
He's going faster and then he's going slower, so he's going to be miles. So he's going to be. So he's going to reach 25 miles per hour. So I guess you could just like figure out the time.
Yeah,
and then
5
he
miles
beats him.
per minute.
Yeah. So then
Is that right?
he's going to be in this
No, not 5
area
miles
that
per
much
minute.
longer than this person.
25 miles per hour would be divided by 60.
My brain's not working today.
Well, if you go 25 miles per hour, you're going a mile every what? 2.4 minutes.
Miles per hour. I don't know. So you'd be 25 over 60. Would that be it? Would that be the ratio?
That's
Yeah,
miles per
5
hour divided by minutes.
over 12.
So that would be
He saw him doing math and said, "Oh," and ran away.
What are we trying? Are we trying to figure out how long it takes him to go 5 miles?
I think that's one way. I don't know if it's the
That would
best
be
way.
one. Yeah, it's probably not, but I don't know the best way. So that if we do that, it would be you just divide it into 60, so it'd be 2.4, right? Miles per minute. Because if you divide that into 60, that would be 25 miles per hour. So it'd be I think it's 2.4 miles per minute. No, that's not right. No. It's 2.4 minutes per mile. Right?
So then over 5. So then 2.4 times 5, right? That's what we're looking for. 2.4 times 5.
Right. So 12. It takes him 12 minutes
12 minutes.
to go 5 miles. That seems right. Yeah. Because 30 would be 10 minutes. Okay, so 12 minutes.
So he's
And
going to
this
take
one's
a little
going
bit
slow.
slower. Yeah.
Right. This one's going 3 minutes per mile, divided into 60.
And then that's
So
15.
15 minutes.
So
So for 3 minutes, this guy's going 40 miles per hour.
40 miles an hour. And so what's the minutes? What's the minutes per mile on this one?
1.5.
1.5 minutes. So 1.5.
So in the extra 3 minutes, he's gone an extra 2 miles.
2
So
miles.
at 15 minutes, he's 2 miles further.
2 miles further. And then he enters in.
And then they're going the same speed for the last 3 miles.
2 miles. So 1.5 miles.
That takes 1 more minute. That takes 1 more minute. There we go. We got it. It's because they're both going 40, so that's perfect. So 1 more minute. So 16.
That's not minutes. How many miles in miles?
Oh, okay. So
he's 2 plus 1.5 is 3.5 plus 5 is 8.5.
yeah.
D.
Okay, was there a better way?
Watch out, buddy. Stay away.
Was there a
So
better?
when you're walking in, you walk in that way so you don't get on the screen. There you go. Yeah, we're doing math problems, buddy. What are the math problems? I call the AMC 8 from the 2025 test. So you can come over here. Just the camera's here, so you can't be on that side of it. So you can't be on that. There you go. What are we supposed to do? We are.
Distance
Well, we just solved this one. We just solved this problem.
Yeah, we'll see if we're right.
Anti-K, seeing if we're right. He's down there.
What did we say? Did we say D?
Yeah, we said D.
Yeah, we got it.
We got it. We got it right. It was 8.5 miles. Don't come over here. Remember, get your face on the screen. There you go.
The first solution did it our way.
Yeah, you can get the back of your hair so you can back up. Yeah, don't get your face. Gonna walk backwards everywhere. All right, so we got it.
We did. I'm clearing it out.
Do you see better answers?
I read the first one and it was ours, so I thought, okay, that's good.
All right. Yeah, we were the first answer. That's all right.
Let's see. Wait, maybe I got it. Let me read back to center here. There. That should be better. Half of, yeah, it fits. If I just, okay.
Oh yeah, I read this one. Are we on problem 25 already?
No, this is number 20.
20. I read this one when I was getting ready to see if we'd already done it. And I was like, oh, okay. All right.
They're sharing a large block of cheese.
The large block of cheese. Yeah. So we're looking at Sarika. Why is my writing so bad on this? So they started with a half. Sarika had a half, and then it went to a fourth, and then it went to 1/4. Wow.
Oh, so this is like an infinite series.
Yeah, 1/8 is the next one, and then 1/16. About what fraction? And then 16th, 30 seconds. 30 seconds. What's after it? 64th, 64th, 100 and 128. 128, right?
Yeah, it's just going to be a power of 3 more every time.
Yeah, there you go. So I think once we get to 128, we probably stop, right? Because that's getting pretty tiny, too small to see. So I think maybe they're just asking for the 1/2 plus the 1/16.
I mean, the 128th isn't going to change it by a whole lot.
Right.
So that would be 9/16, which isn't a choice.
Right. Can we add, would all of these subsequent ones add up to 1/16 as well?
I'm not good with infinite series, so we could factor out 1/2, and then you have 1 plus 2 to the cube, 2 to the 6. Whoops. No, not 2. Yeah, I'm all whacked out. I got a lot of sleep last night. What's going on? Should be better.
And I have not gotten a lot of sleep.
So 1/2 plus. Wait, that can't be true. Oh, times that.
Wait, how do you get the? So, oh, okay. This is the first one. That's that one, and then that's that.
I just factor out a 1/2 just for fun, just to see what would happen. So it's 1/2 times 1 and a little bit more. And if you factor out another in 8, but then that would change that. 1. Well, I think your intuition. What if we did just a 1/28? So that would be what, times 6? No, 7, 8, 8. So it'd be 8 and then 64. So it'd be 72, 73, 1/28.
So. Yeah, I remember staying on that side there. Dave wants to do math with us. All right. hold them up. There you go.
I think it seems to be approaching 3/5. But it
Okay.
also might be 4/7. I think it's one of those two.
What are these as bigger numbers? Because you said it's 73 1/28. So if you add,
I think
go
I
this-
did it in my head, so it's 50/50.
So what's this in 1/28? So what's that in 1/25?
Well, they're not going to be exact. We could just convert to decimals. 4/7 is 0.571.
0.571.
And 1 4. Okay, and that's 0.6. And what's ours? What's 73 divided by 128? Is it 6? No, it's 5, I think. That'd be 640.
I move my thingy.
So 90. So that's going to be 7. So it's really close to 0.57. So looks like 4/7 is our best guess. I would go with 4/7 and feel pretty confident.
Or 7, yeah. To get because it's at that 0.1. Yeah.
There's probably an easy way to add these up. I don't know it. I don't remember.
I wonder if we could see the solution set on this one.
We can. Let's see if we're right, and if it tells us how to add them up.
Okay.
The answer was
Dave.
A. Yep, there's a formula for it. A over 1 minus R.
What's A?
So A is the first number.
R. A is the first number, so in this case it would be 1/2.
And R is the common ratio. In other words, what we're multiplying each term by.
And that's 1 over 2/3. 1
over 2 to the third, yeah, which is 1/8. So 1/8. Yeah. So 1/2 over 1 minus 1/8 is going to give us the answer. I should have remembered that one. The geometric series. It's been a long time.
Yeah. I really feel bad that I didn't remember that one.
Or that we didn't derive it. We should have derived it ourselves. I don't know how to derive. That should be 4/7. Did you want to work that out or no?
No. Okay.
Our next one looks like graph theory.
Oh, yeah.
Wait, how did we delete?
I'm terrible at, but I love.
That's all of math for me. Yeah. I don't know if I love all of math actually, but
Yeah, do you really love? So this is Dave.
That's Dave.
He's a Kupibara or whatever.
Yeah.
I don't know what it is. He has a leaded bum, so he naturally kind of.
Does he sit in the old gum tree?
Is that
the song?
Is that where Kupibara sit?
Is that the children's song? There's something sits in an old gum tree.
I don't know.
Laugh. I think it's a bird.
Yeah. The Königsberg School has assigned grades. I bet that's named after the person who did this.
No, I think that's the famous Leonard Euler drawing Königsberg bridges, the father of graph theory. Yeah, the father of graph theory. Yeah, that's Euler's.
Yeah.
I think you're right. Nice.
Has assigned grades 1 through 7 to pods A through G. 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The school noticed that each pair of the connected pods has been assigned grades differing by 1 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F?
What?
So are we assuming?
Why can't we just go to the pods and ask what grade they are? Let's see. 1 grade per pod.
Just go here, to here.
By 1 or more. Wait, Each pair of connected pods has been assigned grades different by one. For example, grades 1 and 2 will not be in pods directly connected by. Wait, what? Why? That seems contradictory to me. Why am I not understanding?
So C cannot be 1 and E cannot be 2. Grades 2.
Oh, because D's between them?
No, because they're directly connected by a walkway. So there's this
So
walkway.
what? But C and D can't be 1 grade apart either?
Yeah,
Or
they
they're
can't
not.
be 1 grade apart either.
Then why does it say differing by 1 or more? Because differing by 1 would be differing by 1.
Differing by 1 is differing by 1. You're correct.
Yeah, so what, when they say grades 1 and 2 will not be in pods directly connected, isn't that a difference by 1?
No, they're just saying,
Anyway.
they're just saying that A through G are going to be different. They're going to be 1 through 7.
Mm-hmm.
So I think that's what they're trying to say. So say,
I guess. Because it says, for example.
the
The example seems to contradict the statement before it in my brain, but maybe I'm just weird. I don't understand life.
Yeah. Just change this to 2.
I don't want to change it. They wrote the problem. I want them to change it.
You change it. You're a problem. Yeah. I think that's what they're saying though. I think. So
Okay,
let's
so
just
we're
say,
just so B and D in F all must be in A all must be more than 1 grade level higher than C.
right.
A, B. So if C was 2, C couldn't be 2. That'd be
Or
impossible.
no. So that they may not all be 1 grade higher. They have to be
More than 1 grade apart.
apart. So they
Yeah,
could be less.
right. But C seems like a pivotal thing because
It's got a lot of nodes. It's a common. It's got 5.
5 grades coming out of it, all
Yeah.
but G.
G.
So I'm figuring C must be
7.
or 1.
Yeah. It's got to be 7 or 1. One of those. F also has a lot and is connected to all of them except for D. One, two, three, 4, 5. Yeah. So F and C. So there has to be a
Okay.
difference of 2.
So
How
they're
does that?
1 and 7. So therefore we're already at 8 because we need C and F in our answer. So E is the only other one we need. And E can't be 2 or 6, right?
And we know this one's 6, right? And this one's 2.
Why do we know G6?
Because if we were saying this one was 1,
Why can't that one be
was 7.
7? Okay, it's either.
Yeah, it's either or. So we just pick one.
Okay. But I'm trying. So E can't be 2 or 6. So what's left is 3, 4, 5, right? So
3, 4,
E is
5.
3, 5. Jot that down. Let's see if we can eliminate those. Maybe
6 cannot be 5. Because there'll be, or 8 cannot be 5. So it's either 3 or 4. I feel like this is like a Sudoku.
I feel like it's got to be 4 is what's coming out.
This one could be either 3, 4, or 5.
Wait, D can't be 2 if C is 1.
Oh, you're right. And then, oh, I mixed them up. This has to be 2, and this has to be 6.
6. Yeah.
So that means this one, E cannot be 5. So E can't be 5. 6, 7, 5. So it has to be 3.
Why can't it be 4?
I don't know, because I said it can't.
He said it has to be 3.
Had to be you. Yeah, this is like a Sudoku. However you say that word. 2. Back 6. All right. So then this. So we have 1, 2. Okay.
So A can't be 3. So
A can't be 3.
so B has to be 3 or 4.
5.
That has to be 4.
3
No,
or
it can't.
4.
or
Why
3 or
can't it
4.
be? Why can't it be?
Can't be 2. Could be 5 also.
B? Yeah, B could be.
Yeah.
B could be all of them, right?
No, that's it. 3, 4, 5, right? It can't be 2 because it's next to 1 or 7.
Right,
It'd be
but those are
6.
the only ones left. 3, 4, 5 are the only ones left.
So whichever one A is.
So he could be. E could be. Let's do E cannot be 5 anymore.
Well,
So
then
E could
there
be 3 or
A
4.
A
Right?
can't A has to be 5 because if A was 4, it would eliminate all the choices for B. See what I mean? If A
Right.
was 4, that would eliminate B. Would have nothing.
Right.
So A has to be 5.
There you go.
So
So that means
B.
3, 3, and like I said all along, E has to be 4.
That was my initial thought. Was 4. Wait, why can't it be 3?
Because you already chose 3. Up here, B is 3.
Oh, right. Yeah. It felt like 4 because you have the
All right,
G
so now
had to
we
be
need to
6
add
or
them
10.
up. So
Yeah, it's
7,
12. It's 12.
12, 12.
Yeah. And if we switched the C and F around, it would be the same situation, you think, without doing it? Because we made a guess for C and F. You think switching them would create the same thing?
Yeah, yeah, I think so.
I'm less confident on this one than others, but still over 50%, I think. It is
Yeah.
A.
Yes. That's what I'm talking about.
All right. Interesting. Getting near the end here.
Yeah, where we at?
That was 21. You want another one? Still have enough
Yeah.
brain power left? Okay.
Yeah, yeah. That reinvigorated me. That was good.
That destroyed everything inside of me. So collectively, we're still at 0. It's good.
All right. Well, this could be the last one.
Whatever you need to do. I'm doing just
Uh,
mowing the grass and doing math all day.
yeah, I mowed the grass last night. I think.
Mow the weeds.
Yeah, that's what I got. You have grass. You've been working on it. You said.
We have a drought, so it all died.
All right. A classroom with a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there are at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? All right, classroom has 35 hooks. Okay, so we have hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat. Okay. Suppose there's at least one coat and at least one empty hook. How many different numbers of coats can satisfy? Okay. So we have 35 of hooks and coats, right? So like what we have here. And so if we have coat, coat,
What are you doing?
coat, coat. Right. So this is the beginning. This is the first one that would satisfy her thing, right? At least one coat and at least one empty hook. So empty hook, coat, empty hook, coat, empty hook, coat, empty hook, coat.
That wouldn't be the first. That would be okay if you want to go that way. I was going the other way. One coat. One coat would be one. There's one way to do one coat. Hook
One
18.
coat, yeah.
But you can go that
hook
way
18.
too.
Yeah. If you did it on hook 18, would it would have equal on both sides?
Yeah.
Okay. Because it's an odd number, because 35 is an odd number.
Yeah. So what I'm thinking is we just subtract. If you can subtract and divide it by one more than you're subtracting, it's a possibility. In other words, if we subtract 1 for the one coat, there's 34 more hooks. We can divide that in 2, so it works. If we put 2 coats on, there'd be 33 more hooks, and we need 3 equal groups. 33 is divisible by 3, there'd be 11 empty hooks between, so we can do 2 coats. I think that's the best way, is like start with 1 coat, keep adding, and see if we can do everything. Does that make sense? So if we did,
I did. I had an alternate solution.
Okay.
You do your 1 coat, right? And that's at 17. And I count this one, how many coats we could have, right? At 35. So it's 1. So it's 2 coats. 1 coat for every 2 hooks. So 35 minus, so it's 17, right?
Okay, start over. Sorry, I was figuring out 3 when you started talking. Okay, I'm ready now.
Sure.
Go ahead.
So you have 1 empty and 1 coat, and so that's the ratio of one hook per every 2 coats. So, or 1 coat per every 2 hooks. And so that means we basically divide that by 5, or divide that by 2, and so that's 17, right?
So that doesn't
work. We could have 17. So we have 17 coats. Because you need 1 extra hook at the end. Yeah. So you have 17. So you had 1 coat, and then I found out our max is 17. So can't we just do that? So then 2 is then gonna equal, and then you have 16.
16 what?
Coats.
If you're skipping 2 hooks, you wouldn't have 16 coats.
How many would you have?
11.
You have 11? All right.
Wouldn't you? I don't. 11. Well, why would you have 16? If you skip 2 hooks, there's a coat and 3 every third, so you divide it by 3.
You divide it by 3. Okay.
That's what we're kind of doing the same thing.
Sure.
You're doing it a different way. Yeah, keep your way, and I'll see what happens if we compare our answers. See if it works.
3 and then 4 divided by 4, 35 divided by 4. That's a square root. I don't want a square root. I don't know what number that was. So, but for some of them, you can't do them, right?
Right. Like you can't have 4 coats.
And I think the same is for 3.
You can't have 3 coats. But your 3 might mean differently than my 3.
Yeah,
my 3 means 3 coats. Yeah.
Mine's every 3 hooks. Oops, sorry. I didn't mean to draw that.
I see what you did. See you getting angry at my work. Okay, I think I'm at the end. No, wait, no, I'm not. Then we just gotta get the 1.
Oh. My buddy Chris, he's a smart guy. He says Coat C, empty spaces, C plus 1, answer C plus C plus 1 equals 35. Does that make sense?
I'm still thinking on my last way here. I think it's
You say C plus 1 equals 35. That'd be 2C plus 1 equals 35. 2C equals 34. 5 by 2. C equals 14. I don't know.
all right, I'm right. I'm
No,
ready to think
that's
about this
17. 17. That's not, yeah. So yeah, 17 would be the most coats you can get in there, but it says how many different numbers of coats can satisfy the pattern. So how many different, you're just saying 7?
I'm saying 7.
All right. That
But I'm
sounds good to
curious
me.
if there's a better way to do it with the formula. We're basically, so it would be, the way I was doing it is if you have n coats, you would have 35 minus n divided by,
You're off the screen.
oh.
Divided by.
I can move it. Or let me try. Okay, I'll put it under my other thing. See if this makes any sense. If you have n coats, you would do, 35 minus that number of coats.
Okay.
And then you need to see if you have, like, say you have 1 coat, you would need n plus 1 groupings to split it up, 1 on the left and 1 on the right. You'd have to have 2. So you divide that by n plus 1, and that has to be an integer. So that's not very nice. I don't know what that has to equal. That has to equal 35 plus n. I don't know. I'd have to think about that longer. That's what I was doing. I was just doing subtract the number of coats and then divide that into 1 more group. And if you can, it works.
So if you have 1 coat, you got 1 in there. So then it's going to be 35 minus 1 equals 34 divided by 2, and that gives you 17.
Right. So there's 17 hooks on each side of the 1 coat.
So you put 2 here, and that's going to be 33 divided by 3. That's going to give you 11. That's where you got your 11.
So
there.
11 hooks, coat, 11 hooks, coat, 11 hooks.
And then
I just kept going. 4 didn't work.
4 didn't work.
Because there'd be 31 empty hooks, but you would need 5 groups, and you can't do that.
Yeah. Yeah, I guess that works. I wonder I wonder if you can come up with that with what I was
reverse.
Doing. Yeah.
What were you doing again? So you were doing
I was doing
pattern. You were doing
ratio, yeah. So it's a 1 coat for every 2 hooks.
And you're trying to see
plus 1 at the end. Yeah.
And you're trying to see if there's for 35. So then it'd be for 34, or you could just take away 1. So does that work for 34 hooks? No.
I don't know. All right. Yeah. We'll just stick with your way.
That's interesting. The different ways is what makes it more fun.
Right. I think there's probably one in the problem set. I'm just not the man to come up with it.
Well,
just
I've
like
also
my number system.
I'm looking at my like the leftover hooks. Is there a pattern there? I don't think so. 1, 2. Oh wait, no. 1, 2, 3, 6, 8, 11, 17. It started with the triangular numbers like 1, 2, 3, 6. I'm like, oh, that's cool. But then they're all like factors of. It'd be fun to think about longer. Like, yeah, is there a way to work the other way?
Well,
instead
once
of subtracting
you
the coats, you just find the groups.
Yeah. So your once you get to 5, you're basically done, right? So then, because
Why?
your 8 and your 3 are the same, your 2 and your 11 are the same,
Oh,
and your 1 and your
yeah,
17
there's
are
a
the same.
pattern. That's cool. So you're
So
switching the hooks and the coats around. Yeah. That would have saved time.
mhm. So, but then why does your 6 not work?
Make sure I did it right. So if there's 5 coats, yeah, 5. So that would be if there's
Oh,
6
5
coats.
doesn't work.
Yeah.
Oh, yeah, it does.
Oh, it should be 5-5, not 5-6. It should be 5-5. That's why
5-5. There
I
you
wrote
go.
the wrong number, but it still works.
5-5. There you go. Oops, that was not a
That's
5.
not a 5. You just wasn't just.
I've been working with 11 too.
So there's the symmetry.
Oh, man.
Symmetry makes sense because you're switching hooks and shirts.
Yeah.
So we're set on D.
Indeed, yeah. Chris, my buddy Chris is in. You can join us, Chris. You could join up. Does that make sense? He's following. He's saying
Oh,
even though the hook's bad.
there is a pattern here. They gave one kid gave a formula.
Okay. Well, isn't you came up with a formula too? It's different than yours.
No, like an actual one you can solve. Mine was just like a guess and check pattern, but they actually had a formula you could solve for the thing you're looking for.
Mhm.
But anyway, I think solution 2 was like mine. Oh, there's another formula. Whoa, it'd be fun to read all these.
Is there anything that looks similar to mine?
Neat
No.
trick. All right, there's always set number of cosine. Yeah, I think that one's close to like a hybrid of ours. Maybe solution 5. I don't know. Interesting. All right, we got another one right. Look at us go. This is like an hour-long test, so as long as they give us 3 to 4 hours, we'll get it.
And we can work together.
And teamwork, yeah. And the internet. No, we didn't use the internet. Use our brain.
Yeah. There you go. All right. I guess I'll get going and get see if I can help the family. Thanks for doing that. That was good. I've been wanting to get this set up and do it again, do some more.
Yeah.
So how many more do we have left to do? We still have a few more.
3.
Right. 3 more. So we'll at least have to do it at least one more time. And then we can go
Maybe
to
twice, yeah.
2024. Try to make it through.
Go to AMC 10 and just get destroyed.
Yeah, we could. Yeah, we should mix in some of those just to kind of like, wow, I have no idea what they're talking about. So.
All right.
All right.
Make sure this doesn't go out on the internet.
It's already there.
I can go away. All right. See
You're
ya.
gonna report it for obscene content.
I'm tempted. Get on there. Get this taken down. All right. Have a good weekend. See you next time.